Visit themoreshow.co.uk/shop to purchase products and services from your favourite past guests. If you're new to this site, you can also catch up on the previous television and radio shows through YouTube and the More Show website.
The More Show is supported by Mindscape, Paranormal and UFO Matrix magazines, available for download on all major digital platforms. The More Show is in partnership with Ozark Mountain Publishing, taking readers beyond the unexplained. The comments and views expressed on The More Show are those of the people that make them and do not necessarily reflect the view of Kevin Moore, The More Show, or this radio station and its affiliate or sponsors. This show is for entertainment purposes only.
Broadcasting from the UK and across the world on TV, radio and online. I bid you all good morning, good afternoon, good evening, wherever you may be in all the world's time zones. This is The More Show, and I'm your host, Kevin Moore. For the next hour, I'll be covering subjects that will open up your mind and provide you with information you may have never heard before. On today's show, I'm joined with Ronald Mallett Phd. Now, Dr. Ronald is a professor of theoretical physics at the University of Connecticut. He is also a member of both the American Physical Society and the National Society of Black Physicists. He has a BS, MS, and PhD in physics from the Pennsylvania State University. At age 10, Ron's life changed forever when his beloved father died of a heart attack. Ron was overwhelmed with grief. He read a copy of The Time Machine by H.G. Wells. He was then determined to make Wells's fantasy a reality by going back in time to see his father. Remarkably, not only did the boy from the Bronx stick with his vision by becoming one of the country's first African-American PhDs in theoretical physics, but Mallett has, according to many peers in the field, developed new theories related to Einstein's general theory of relativity, that the plausible argument for the existence of time travel into the past. In addition, Ron's time travel research has been featured in an hour-long TV special on the Learning Channel, The World's First Time Machine. Professor Ronald Mallett, welcome to the show.
Well, thank you. It's a pleasure to be with you.
Now, this is going to be a really interesting interview because anything to do with time travel, and they've always been my favorite movies as well. So, now, this all started when you was age 10. That's right, that your journey started, as in you lost your father.
Yeah, that's right. I mean, it began for me with tragedy in my life. My father was really the center of my life. For me, he was bigger than life. I was the oldest of 4 children, and we lived in the Bronx, and my father was a television repairman in the Bronx. And the thing is that he seemed like he was in perfect health. I mean, he worked hard, and but he spent a lot of time with us as children. And as I said, he seemed to me like he was invincible. And I didn't realize, and none of us as children realized, that he had a weak heart. And so when he died of a massive heart attack, when he was just 33 when that happened, and I was 10, I mean, it shattered my world. I mean, it really tore my world apart. I reached a point where I really didn't care whether I lived or died. In fact, I really would have preferred to have been with him. And it was something, I was inconsolable. But one of the things that he left me a lot of gifts. I mean, when I was growing up, he would give me scientific toys like a gyroscope and crystal radio set. But he loved to read, and that's something that I got from him as well. And I loved reading science fiction. And about a year after he died, I came across what's called a Classics Illustrated version of The Time Machine by H.G. Wells. And that famous classic changed my life, because when I saw the cover of it, it just seemed to reach out to me. And when I read inside it, it said that scientific people know very well that time is just a kind of space, and we can move forward and backward in time just as we can in space. And when I saw that, it hit me like a thunderbolt. I said, if I could build a time machine then I could go back into the past and see him again and tell him what's going to happen, and maybe that I could change things. So in a sense, that was the beginning of my real intellectual journey, was that beginning. The thing is that I knew that it was a fantasy, but I thought that there might be something to it. In fact, what I did was, as a child, I even tried to follow the cover design that they had for the time machine, and I tried to put it together with bicycle parts and everything that I had, and it didn't work. But I remembered that it said that scientific people know very well. So I knew that that had to do with something with science. And for me, the second book that changed my life happened a couple of years after that, when I was about 12 or 13. I came across this paperback called The Universe and Dr. Einstein. And that was the second book that changed my life, because even though I couldn't understand everything, in fact, the cover of the book is what caught me, because it had a picture of Einstein next to a giant hourglass. And I said to myself, this must mean that this person has something to do with time.
Yeah.
And so I went through it, as trying to understand as much as I could. And it did say, in fact, that Einstein said that time could be altered. Now, an interesting thing about Einstein is the fact that, for me, it's always been interesting, is the fact that my father died in 1955, and Einstein died in 1955. And I can actually remember as a child seeing the headlines on a newspaper about his death. And this was actually just about a month before my father died. So it's almost like there's a fate that's built in there. And Einstein has been as much my part of my life as the time machine itself. So, I mean, for me, that was really the inspiration. The thing is that it's funny, because one of Einstein's famous sayings is that imagination is more important than knowledge. Knowledge is limited, but imagination encircles the world. And what he meant by that was just the fact that it's imagination that's the engine that drives us. It's curiosity, human curiosity. And then we acquire the knowledge that we need to satisfy our imagination. And for me, that's what happened. The Time Machine by H.G. Wells was sort of the imagination part. And then I realized that Einstein was going to be the knowledge part. It was going to be able to provide me with the information that I was going to need in order to build a time machine. And I should say that it wasn't like just as simple from that. All of a sudden, I decided I was going to have to go to college, and I started. It was much more complicated than that. After my father died, I
can imagine. And would you say then that his passing, there was a gift in that, in a sense that it drove you to do what you've done and to get into physics?
Oh yes, I mean that exactly. It's what created the passion for me to go into physics, and I don't think that I would have if I hadn't had that stimulus.
No. And I guess, getting a college fund and everything else, it wasn't easy.
No, as a matter of fact, it was very hard. We were so poor, I wasn't able to go to college right away. In fact, this was during the Vietnam War era when I graduated from high school. And what I realized is that if I could go to the service, in the military service, then I could save the money. And then that way I could go to college after I got out. So I actually enlisted in the United States Air Force as an enlisted man in order to get the money that I needed. And the GI Bill was the way in which I actually was able to go to college.
Right. And one quick question as well. With the passing of your father, I mean, how did that shift you as you grew up in a sort of religious or spiritual way?
Well, and that's a very, very good point. The thing is that we were a religious family to begin with. And the thing is that I've always had this faith in God. The thing is that for me, it actually deepened my feeling of God. I mean, I think that, to me, religion and science aren't all that different. They try to answer fundamental questions, but they try to answer fundamental questions from two different standpoints. And the thing is that for me, trying to understand the mystery of death, because now I was confronted with something that was a great mystery, death. That for me meant that there was something underlying it. And so I really felt that by going into science, I was actually going to be able to understand this mystery that God has given us, which is death.
Right. And I suppose as well, part of the challenge, being a sort of, an African-American physicist in a sense, I guess that path to get where you've got has not been easy.
You're quite right. It wasn't easy at all. As a matter of fact, it was very difficult. When I got my PhD in physics, at the particular time, there were 20,000 physicists in the United States with PhDs. And I was one of 79 African-American physicists with a PhD. So I was among the first few with a PhD. In fact, in my area, theoretical physics, it was even rarer. So it was, and the thing is that there was a lot of, unfortunately, underlying prejudice about the intellectual capabilities of African Americans, and sadly, it came sometimes from physicists.
Yeah.
I'm sad to say there was a very famous physicist, was a Nobel Prize winner. He was one of the co-inventors of the transistor, William Shockley. In fact, there was a book that was written about him called Broken Genius some years ago. And he actually made a statement, and the essence of it was that he felt that African Americans were intellectually inferior. So in a sense, I would have been considered sort of an impossibility.
Well, you've done very, very well for yourself, and I'm sure your father's very proud of you. And so let's get into it then. Is time travel possible? Because as far as I understood, from my school days, that Einstein did state that time travel was not possible, but you're sort of rewriting this, aren't you?
Well, Einstein actually said that time travel could be. Einstein didn't address the question of time travel directly. Let's put it that way. What Einstein did show was the fact that it opens up the possibility, because in the classical theory of physics, Newton's theory of physics, time is something that's rigid. It's not possible to change it. In fact, Newton explicitly says that time is absolute and nothing can alter the flow of time. That is what Einstein changed. Einstein's work actually showed that this river of time could, in fact, be altered. And that was the thing that excited me, because what Einstein said was that, as opposed to Newton, Einstein said that there are many ways of changing time. And the two fundamental ways of time are actually underlying in the two different theories that Einstein developed. Einstein developed two basic theories. One was called the special theory of relativity, which he developed in 1905. And that theory, the essence of that theory, is that time is the limiting speed of the universe. That is to say, no signal can go faster than the speed of light. Okay. The thing is that what this means is that if light is the absolute measure, then something else has to change, because it turns out that if you're trying to move with respect to light, the speed of light stays the same no matter how fast you're moving relative to light. Light doesn't change its speed, but something else then has to change, and that something else is time. What Einstein showed in his special theory of relativity is that speed can alter time. That is to say that the faster you move, the more time slows down. So time for a moving clock slows down. Now, when Einstein says time for a moving clock slows down, it's not just simply a mechanical clock. You have to realize that your heart rate is a clock, okay? That means that if you were moving fast enough, your heart rate would slow down. Now, you wouldn't notice it. It would be other people who were watching you that would see your heart rate slow down. For you, you wouldn't feel the effect, but they would see that you're not aging as rapidly as everyone else. So this means that if you were traveling in a rocket that was going fast enough, then you would actually age less than everyone else. And this allows for the possibility of time travel into the future, because, and if you think about it, this is the way in which it's portrayed in some movies. That is to say that if you're traveling through time and you are not aging the way everyone else is, then when you arrive in the future, you'll actually be younger than everyone else. So you could actually end up in the future traveling, let's say, close to the speed of light. It may only take a few years for you to travel 100 years into the future. So by traveling fast enough, you can actually go into the future. So the special theory of relativity really opened up the possibility of real time travel. Now, you might say, well, wait a minute, has this been shown? Is this not only has it been shown, it's been shown in dramatic ways, both on the large scale and the small scale. On the large scale, this was back in about 1971. What they did was to take two atomic clocks. As you know, atomic clock is the most precise timekeeping mechanism that we have. They put one of the atomic clocks on board an ordinary passenger jet. The other atomic clock, they kept at rest at the Naval Observatory. What they did was to fly the passenger jet close to the speed of sound around the world. When they brought it back, the passenger jet back, they found that the clock on the passenger jet had actually slowed down relative to the clock that was at rest at the Naval Observatory. And this means that those scientists that were on board, their heart rate had actually altered as well. That means that they were younger than their counterparts who were at rest at the Naval Observatory. Now, you might say, wow, this should have been big news all over the world. However, the effect was very, very small, because even though they were traveling at the speed of sound relative to the speed of light is slow, and the effect gets larger the faster that you go. But it did demonstrate, and it demonstrated accurately, that time is affected by speed. And this passenger jet actually had gone fractions of a second into the future. Now, the thing is that this is just a baby step. When we have rockets, and in fact, NASA many years ago was looking at rockets that could potentially go close to the speed of light. Some of them had exotic names like ion engines. Now, once we have those type of rockets, it will be an interesting sociological problem in the future, because astronauts that are traveling in these rockets close to the speed of light, if they happen to have families, there'll be the weird situation that if they go out and come back, they may have only aged a few years, but when they come back, their children may have aged decades. They could actually come back and find that they're younger now than their children. They will have traveled into the future. It sounds like science fiction, but we've actually seen the baby steps of that with this result that's been done at the Naval Observatory. And I should point out a hallmark of science, real science, is verifiability. I mean, there's a lot of stories about, things that happened and they haven't been able to verify.
Sure.
This type of effect has been verified again and again and again. That's an important thing. Verifiability and repeatability is a hallmark of real science. So we have seen the possibility of time travel into the future. Now, it's actually even on a more dramatic scale when we look at subatomic particles, because there are some subatomic particles that only live for a fraction of a second. Now, I know most people have heard of this thing called the Large Hadron Collider.
That's right.
That they have in CERN. Okay. The thing is that the purpose of that Large Hadron Collider was to actually smash these subatomic particles together in order to understand fundamental forces of the universe, and in particular to see if there was this particular particle called the Higgs particle, which is actually sort of gives mass to some of the other particles and sort of acts as a glue for some of the forces. The thing is that whenever they turn that machine on, they accelerate these particles close to the speed of light. And some of the subatomic particles that can only live for normally just millionths of a second, they have been able to show, and they do this every time they use the machine, that they are able to have these particles live 10 to 20 times longer than they normally would. What that means is that they are, in effect, sending these particles into the future. So the Large Hadron Collider is sort of acting as a time machine for subatomic particles, not for human beings, but for subatomic particles. Well, it's actually sending them into the future.
Well, that makes, I mean, that's interesting, isn't it? I mean, what if the work being done there, some of it is covert and it's not all being talked about to the public of what they're using it for?
Well, the thing is that sending things to the future would be interesting, but the thing is that it wouldn't get them anywhere as far as, the thing is that I think that what they would like to do is be able to send things into the past, and you can't do that with speed. I should mention that because of the speed limit of special theory of relativity, no matter how fast you can go to the future, but you can't go to the past. So it's a one-way trip.
Right.
And
well, just after we're just going to take an ad break there. I'm so sorry. Sure. Stay tuned, and we'll be right back.
The Moore Show is supported by Mindscape, Paranormal and UFO Matrix magazines. Available for download on all major digital platforms.
If you like what you watch, then don't forget to follow us on Facebook and Twitter for the latest updates on The Moore Show. Remember to subscribe to our YouTube channel for new weekly television and radio shows.
The Moore Show is in partnership with Ozark Mountain Publishing, taking readers beyond the unexplained. The comments and views expressed on The Moore Show are those of the people that make them and do not necessarily reflect the view of Kevin Moore, The Moore Show, or this radio station and its affiliate or sponsors. This show is for entertainment purposes only.
Welcome back to the show. I'm still joined by my guest, Professor Ronald Mallett, author of the book Time Traveler, a scientist's personal mission to make time travel a reality. Dr. Ron Mallett, welcome back to the show.
Thank you.
Now, just before the ad break there, we were just going to get into, some of Einstein's theories, because there was two theories, I think, on speed and time, and that of general theory of relativity as well. So let's just, go into that area. That's
right. The thing is that Einstein's first theory, the special theory of relativity, which I said he developed in 1905, the thing is that what he realized was that theory was limited because of gravity. Now, in Newton's theory, there's no speed limit. And in fact, gravity, which is the force that holds us to the Earth and keeps the Earth in orbit around the sun, according to Newton, gravity can travel faster than the speed of light. Gravity can be, in fact, according to Newton, gravity travels instantaneously. I mean, what that literally would mean is that, in fact, one of the interesting things that sometimes people don't think about is the fact that when you look at the sun in the sky, the sun is 93 million miles away from us, and light travels at 186,000 miles per second. It actually takes 8 minutes for the sunlight to get from the sun to the Earth, 8 minutes. And if you think about what that means that you never see the sun the way that it is now. You only see the sun the way that it is 8 minutes ago. However, when it comes to gravity, according to Newton, the gravity of the sun there that's holding us travels instantly. And Einstein said that cannot happen. Not even gravity can travel faster than the speed of light. In order to correct that problem, Einstein spent 10 years developing a second theory. It was called the general theory of relativity, and essentially it's Einstein's theory of gravity. And I should mention the reason why it took him 10 years was the fact that the level of mathematics that he had to understand was much, much more sophisticated, much more complicated than what he had for the special theory of relativity. It involved what was called at the time the absolute differential calculus, as we now call tensor calculus. And he had to learn that in order to develop his general theory of relativity. But according to the general theory of relativity, not only now does gravity have to travel at the speed of light, but it turns out that gravity affects time. That was the fundamental portion of Einstein's theory, that gravity can actually alter time. And what Einstein meant by that is the fact that gravity here at the surface of the Earth is stronger than gravity at higher altitudes. And Einstein said that a clock here at the surface of the Earth, where gravity is stronger, is actually running slower than a clock at a higher altitude, where gravity is weaker. That clock would be running at a different rate, in fact, faster than the clock at sea level. Now, once again, you might say, has this been shown? Not only has it been shown, but people aren't aware. It's now part of our everyday life. And what do I mean by that? It's called GPS. The GPS system, which is something that I use in my car all the time when I'm going to a place that I have never been before, it allows us to find our location. Now, The way the GPS system works is the following. Right now, about 12,000 miles above this, there are 24 satellites in what are known as geosynchronous orbits. That is to say that they're satellites that are covering a certain portion of the Earth at any given time. And the way the GPS system works is the fact that the satellites have a clock in them.
Yeah.
And your unit in your car has a clock in it. The satellite sends a signal at a certain period of time, and it reaches your unit at a certain time. Okay. And so you know the time that the signal was sent, you know the time the signal was received. And in physics, it turns out that if you know time and you know speed, you can compute distance. It's a very simple fundamental relationship. And the speed in this particular case of the signal is actually the speed of light. That's the speed of the signal from the satellite to your car. So by knowing the speed and knowing the time, you can compute distance. The problem is that when the engineers were first initially setting up the system, it wasn't working. It was actually giving wrong locations. And when they consulted with the physicists, what they realized was they forgot to take into account Einstein's theory of gravity. Because since gravity at the surface of the Earth, which is where your car is stronger than gravity aboard those satellites, which are very far away from the Earth, that means that, according to Einstein, the unit in your car's clock is actually running slower than those clocks on board the satellite. That means they're out of sync. They're getting out of sync because they're running at different rates. So they actually had to use computers to calibrate and take into account the fact that the gravity is affecting the time on board the satellite in a different way than it's affecting the unit in your car.
Right.
So we actually do know in a very practical way that gravity affects time. Now, it turns out that it's gravity that can allow us to have the possibility of time travel into the past, because with gravity, not only can you slow time down, which leads to the same sort of effect as special relativity, but you can actually warp time using gravity. That is to say that you can bend time and bend space. And it turns out that if you bend time in just the right way, that is to say you make time into a loop, you can actually alter time and go into the past. So by using Einstein's general theory of relativity, it allows for the possibility of time travel into the past.
Okay.
So even though the special theory won't do it, the general theory can lead to the possibility of time travel to the past.
Now, Dr. Mallett, just so I understand this, that the only gravitational body that will slow down time is a black hole, is that right?
That's right. As a matter of fact, you might say a black hole acts as a natural time machine, because just to remind you what a black hole is, a black hole is essentially a star that has reached the end of its life. That is to say, all stars, including our sun, operate as hydrogen-burning systems. That is to say that essentially what happens is that you have hydrogen atoms that are crashing together. And this is what's called thermonuclear fusion. And as they fuse, they become helium. The hydrogen atoms go up the scale and become helium. But the little bit of difference of mass between the two is what gives off the energy that we get here at the Earth. Now, the thing is that eventually what happens is that internal furnace will actually begin to get used up. And remember, the way it's actually happening is that normally there's sort of a balance between the internal pressure of the sun and the gravitational force of the gases of the sun. And they're in a balance. Once that internal furnace starts getting used up, then the star will actually begin to collapse. And as the star begins to collapse, the gravitational field of the star will actually start escalating. It'll get greater and greater and greater. It'll reach a point where the gravitational pull of the star is so great that the light that tries to get out from the star will actually get pulled back to the star. So if all of the light gets pulled back to the star and you're standing outside, then you see nothing. That's all a black hole is. A black hole is just simply a star that has collapsed to a point where all of the light gets pulled back to the star. And so you see nothing. When they talk about a black hole, it would really, if you were able to see it, it would look more like a sphere that would be a black nothingness sitting there in space. The thing is that for us, fortunately, the way which we know that they're actually out there is that if these black holes have another star next to them, a regular star, the gases from that star can get pulled into the black hole, and it can create sort of a halo effect around the black hole. In fact, that's what you see in the popular representations of a black hole. That halo is actually due to gases that are coming from another star, not due to the gases of the black hole itself. So the thing is that the gravitational field of the star not only affects light, but it affects time. And if you were to get close to a black hole without going into it, you don't want to go into a black hole, but if you get close enough to a black hole, time would slow down nearly to a halt. So if you were coming in, you could spend maybe a few hours next to a black hole. Hundreds of years could be passing for everyone else. So once you left the surface of the black hole, area of the black hole, you would actually find that could be centuries in the future. So a black hole actually acts as a natural time machine.
I mean, with the black hole theory there as well. I mean, obviously, that's not on the nearest horizon to sort of travel to a black hole. So, what is your idea then for time travel? Because obviously, light does play a part in your theory as well, doesn't it, of creating gravity?
Oh yes, in fact that is the key portion of my theory. I mean, what I realized, in Einstein's theory, this is another thing that makes it different from Newton's theory. In Newton's theory, the only thing that can create gravity is matter. For example, the Earth creates a gravitational field which keeps us anchored to it. The sun creates a gravitational field which keeps the Earth in orbit around it. Thing is, however, is that in Einstein's theory, not only can matter create gravity, but it turns out that light can create gravity as well. That's a fundamental aspect of Einstein's theory, and that was the key to my breakthrough, because what I realized is that, and you can see the logic of it, if gravity affects time and light can create gravity, then light can affect time. So by using light, we can actually manipulate time based on Einstein's general theory of relativity. Now, I should mention I'm a theoretical physicist, and so what I had to do was first learn Einstein's theory. But then what I did was I had to actually create a theory in which what I wanted to do is to see if it was possible to manipulate time in such a way that it was possible to go back into the past. And I was able to do that. What I realized is that if you create a circulating pattern of light, and by that I mean if you take light and you get light to move around in a circulating path, and you can do that by bouncing it off mirrors or having more than one laser. You have several lasers, you can create a loop of light, essentially. And this loop of light will actually allow for the possibility of time travel back into the past. Now, I should mention that in Einstein's theory, what we call the gravitational force is actually a property of space. That is to say that what we call the gravitational force is actually, in Einstein's theory, a bending of space. It's actually a property of space. And so this notion of space and time are linked to each other. That is to say, in Einstein's theory, when you bend space, you actually bend time. And that bending of time shows up as time slowing down. And if you could twist time, okay, then you might be able to go back into the past. Now, the thing is that how do you twist space and time? What I like to do sometimes to illustrate to people is with a simple cup of coffee. And if you think of the coffee in the cup as being like empty space, and you think of the spoon as being like the circulating light beam, then you know what happens to the coffee when you stir it around. Okay, the spoon creates a swirling of the coffee. That's what the circulating light beam does to empty space. It actually causes a circulation of the empty space. Now, you can't see empty space, so how do you know that that's actually happening? Well, when it comes to the coffee, you can actually know that the coffee is swirling around. You can see it, but another way of seeing it is if you put a coffee bean in the cup. If you put a coffee bean in the cup and you stir it around, then what's going to happen is that the coffee bean is going to be dragged around by the coffee. So you actually could see the motion of the coffee due to the coffee bean. it turns out that you can do the same thing in space. That is to say, if you put in a subatomic particle called a neutron, and a neutron is part of practically every atom, okay, with the exception of hydrogen in its purest form. Every atom in the periodic table has neutrons in it. And the thing is that if you put a neutron into the empty space and you turn on the circulating light beam, it will actually drag the neutron around. The space will actually get dragged around by the circulating light beam, and the space will actually drag the neutron around. Now, it turns out in Einstein's theory, space and time are linked to each other. Whatever it is that you do to space also happens to time. Now, even though we're unconscious of it, all of us are moving along time in a straight line from the past to the present to the future. We're not aware of it, of course, but we are. Okay. The thing is that we can alter that, however. If we twist space enough, we can actually cause the straight line of time, okay, going from the past to the present to the future, we can actually twist time into a loop. And if you think about that, that means that you could actually start out at the past, go to the present, and go to the future, but you've twisted time into a loop. So you can actually go from the future back into the past. So this allows for the possibility of time travel, and that's what my theory is based on, is to actually say that you can use circulating light, in particular laser light, because you can control that. You can actually use circulating laser light beam to twist space and eventually twist time. And this would allow for the possibility of a time machine based on circulating light. And that was the theory that I developed. And it's important to realize that the theory is anchored solidly in Einstein's general theory of relativity. And my colleagues have checked the equations. And the thing is that it's a valid theory. The question, of course, is technological. That is to say that, okay, I've been able to show this mathematically, but is it possible to do it technologically? Now, the gap between technology and theory is actually, it's something that is important to understand. Einstein created the equation equals mc squared. Einstein did not build nuclear reactors or the atomic bomb. Okay, that was done by experimental physicists and engineers. The thing is that if it hadn't been for essentially the Second World War, it's likely that it would have been decades still before we were able to use atomic energy. The thing is that it's the same thing with this, essentially with time travel. It's a matter of funding. It turns out that even though the theory says it's possible and it's anchored in solid physics, in order to turn it into a technological device, it's going to require a lot of money. Okay. And that's essentially when people ask me, well, how are things going with the research? I tell them that the theoretical side of the research is going very, very well, but the experimental side of it needs funding.
And just we were going to put the graphics on the screen now with your model with the mirrors and the lasers, and that's the principle you were discussing just there as well. That's right.
Right. Okay. That's right. That the circulating light is in fact exactly the principle that's behind what I'm doing.
And the idea would be to put an object in this circulating light, or?
Right. Well, the thing is that eventually, I would like to be able to send information back into the past. I'm not interested in that. Was not my goal. I mean, originally as a child, my goal was to try to go back into the past myself. But the practical side of this is to try to see if information can be sent back. And in many ways, trying to send information back in the past is even more important than trying to send people back, because we are the information age. And people have asked me, well, what else would you use a time machine for besides being able to see your father again? And to me, as it would be an early warning device. Imagine if we had a way of sending information back into the past. Then we could warn ourselves of future disasters. And we would be able to, for example, the tsunamis and the hurricanes and earthquakes, all of the things that take thousands of lives.
Yep, no, absolutely. I mean, this is just incredible stuff. And we're just going to take a quick break and we'll be right back.
The More Show is in partnership with Ozark Mountain Publishing, taking readers beyond the unexplained. The More Show is supported by Mindscape, Paranormal and UFO Matrix magazines, available for download on all major digital platforms. The More Show is in partnership with Ozark Mountain Publishing, taking readers beyond the unexplained. The More Show is supported by Mindscape, Paranormal and UFO Matrix magazines, available for download on all major digital platforms. The comments and views expressed on The More Show are those of the people that make them and do not necessarily reflect the view of Kevin Moore, The More Show, or this radio station and its affiliate or sponsors. This show is for entertainment purposes only.
Welcome back to the show. I'm currently joined by Professor Ronald Mallett. Ronald, welcome back to the show.
Thank you.
Now, just before the advert break there, you were just saying about some of the positive sides to time travel, you know, warning people against disasters, no matter what it may be, natural or man-made. But there is that question in my mind saying, well, what if it was a soul's destiny to check out when it did? Would we be changing would we be playing God in a sense?
And that's a good point. And I've actually been asked that whenever I've given public lectures. And the thing is that, and once again, I want to remind you that I am a religious person. I'm a very firm believer in the existence of God. The thing is that I also am a believer in the fact that we were given these intellectual gifts. And to me, it's the opposite. When we don't use our intellect to the fullest, to me, then that's flying in the face of God, because we were meant to use our brain.
Yes.
So it's the opposite.
Yeah, and also I suppose we need to get into a bit of the ideas on parallel universes, because, and this will link back to what we're saying now, because your theory is that once you've left this time and go back to, go to the future or the past, if you had the ability to go back, if the technology was there in the time frame for you to rebuild the machine in a sense, and you went back to your time frame, it wouldn't be the same universe.
Well, the thing is that that's a good question. In fact, that's one of those philosophical questions that has puzzled scientists as well as the public, and that is to say, when you go back into the past, if you're going to the future, there's really no paradox. But if you go back to the past, there's what is known as the grandfather paradox. And the way in which it's the form that I like to talk about the grandfather paradox is, suppose that you go back in time and you prevent your grandparents from meeting each other. Well, if your grandparents never meet each other, they don't have your parents. And if they don't have your parents, then they don't have you. So how could you go back in time? That is this famous grandfather paradox, where you could actually go back and do something that could potentially seem to erase your own existence, which is a paradox. The thing is that it turns out that physics itself may have a way out of this paradox, and it actually comes from the other pillar of physics. We've been talking about relativity physics, but the other pillar of modern physics is quantum mechanics. And quantum mechanics is a very, very strange thing. In many ways, quantum mechanics is even stranger than relativity. It tells us that you can't make predictions exactly about the future. There's a very famous principle called Heisenberg's uncertainty principle. The essence of that principle says is that we can never predict exactly what's going to happen next. In classical physics, if we had all the information we needed, we could actually predict what's going to happen in the future. According to quantum mechanics, there's no way that you can ever have all of the information that you need. You can only talk about the probability of what's going to happen next. And there was a physicist named Hugh Everett III who was at Princeton at the time. And this physicist actually applied the notion of quantum mechanics to the universe as a whole. And what he found was the very strange idea that if you actually are consistent and apply quantum mechanics to the universe as a whole, then every alternative that can happen actually gets played out. Let me be specific. Suppose that at lunch you were trying to make a decision between having a cheeseburger or a tuna sandwich. At the instant that you decided to have the cheeseburger, there would be a split of the universe. There would now be a universe in which you had the cheeseburger, but there would also be a separate and just as real universe in which you have the tuna sandwich. And the thing is that this would be happening not just simply for you, but for every single decision that everyone is making. That's mind-boggling to think that all of these universes are splitting off. But this is the notion of parallel universes, which says that every alternative that can happen gets played out, but it gets played out in a different universe. That's the basis of parallel universe. Originally, it was called many-world interpretation of the universe. Now, it turns out that this notion, if you apply it to time travel, it leads to some very, very strange effects, because it says that if you go back into the past, at the moment you arrive in the past, you cause a split in the universe. You arrive in a universe, but it's not the universe that you came from. So in that universe, you could do something like preventing your grandparents from meeting each other. However, there was a split when you arrived back. The other universe doesn't have you in the past. And so that's the universe that gives rise to you. So that means that there is no paradox, because no matter what you do in that other universe, it's not going to affect the original universe that you came from. That's the notion of how parallel universes can be applied to time travel, and it leads to the possibility of no paradox. So it would mean that if you were sending information to warn someone in the past, or try to improve your device, you would be sending information back into a parallel universe, and it would affect their universe, but not your original universe. Now, I should mention, this is a caveat, is the fact that even though this is a real possibility based on physics, it doesn't mean that this is the way in which the universe will actually play things out. The only way we're really going to know how it gets played out is when we actually do the real experiment.
You know, I mean, what you've just described there, it's almost like different dimensions in a sense. And the crazy thing about it is, in that other universe that you've traveled back to, if it is a parallel universe, your consciousness from your original universe is still the same. So that begs a question that, you know, that some people that I've interviewed about, you know, consciousness splitting, and that we have multiple lives in multiple universes. Could this be the case, which then goes back to what we were originally saying, that if you change something in a timeline, that, you know, whatever it may be, someone not passing, or, you know, whatever it could be, maybe you're not playing God. Maybe you've made no difference in the original universe you've came from, just where you've ended up.
That's right. However, as I said, the question is that the way in which the universe plays? It may be, and this is even stranger, that reality does get altered in a way that we can't even begin to imagine, but that means that we really do alter it. But I don't see that it means that we're playing God. Once again, it gives us a responsibility that we need to deal with. It's the same as with any technology. No matter how simple the technology is. One of the things that my stepson pointed out was one time when we were having this discussion and someone was pointing out the dangers of technology, and he picked up a butter knife and said, well, this is technology, and I can use it to butter bread, or I can use it to stab someone. That's the alternative of any technology. So just coming out of the cave, it's a responsibility that we have, and we just we shouldn't avoid that responsibility. And when time travel happens, and it will happen, that's one of the things that I try to get people to be sensitive about, is the fact that it's going to require a huge responsibility on our part. It's never going to happen that everyone's going to have their own particular personal time machine. That would be like the equivalent of saying that everyone has their own nuclear reactor. There's going to be a regulatory agency that's going to be involved in this process eventually. And it's going to be something that's going to have to be monitored. And there will be abuses, and there will be temporal enforcement officers who have to take care of the abuses. The thing is that it's going to be something that is going to lead to a very strange world. But as I said, that's just one possibility. It could be that if we have if the parallel universe paradigm holds, then that's not going to be a problem, except for the fact that whatever we do when we send information back is going to definitely affect someone else's universe, which leads to another moral issue.
Well, let me ask you something. I mean, we get a lot of UFO investigators and stuff like that, right? And you think to yourself, well, could some of these craft, if they ever do exist, could they be from the future? Could they be us from the future observing what we're up to now, or trying to change the course of something?
That is another good question. The thing is that what a lot of people don't realize is the fact that since the 1990s, there has been a revolution in astrophysics on a number of different levels. Not only have we found out that the universe is expanding more rapidly than we thought, but the other thing is that we've actually found what are known as extrasolar planets. Now, what extrasolar planets are these are planets that are orbiting other suns. It wasn't really known. I mean, it was hypothesized, but it wasn't really known whether other stars could have solar systems associated with them the way we do. I mean, in other words, we know that there's suns out there, billions of them, billions upon billions. But the question is that they have planetary systems. And in the 90s, we were actually able to observe that there are planets that are orbiting other stars. Now, what this means is that some of these planets are going to be too close to their stars, and they're going to be too hot, and there's going to be some of them are going to be too far away. Now, you can probably see where this is going. Astrophysicists have actually discovered a group of planets which they have called Goldilocks planets. And of course, that means that these planets are just right. That is to say that it's possible that they are at the right distance, that they could potentially have life on them, that they're not too close or too far away. What this means is that there's a scientific basis for the real possibility that there are planets out there that are like our planet. And in fact, just in the neighborhood of our solar system, we've actually found several hundred of these extrasolar planets. And this is just in our galaxy, neighborhood of our galaxy. And of course, there's billions of galaxies out there. So the thing is that it's now considered to be a pretty reasonable scientific consideration that the universe is probably teeming with life. Now, the question, of course, comes up is whether that life has found us or not. That's a different story. But the question does happen that it's likely, in fact, it's very likely that there are some of these planets that have life and civilizations that are very much more advanced than us, and they have, in fact, developed time travel. And if they have developed time travel, it is possible that they could utilize it to go back to our distant past if they've invented their machines far enough in the past, okay? Because I should mention that there is another limitation associated with time travel in the past, which is to say that you can't go back in time earlier than when you turn the machine on. For example, you turn the machine on today and you leave it on for 10 years. You can come back 7 years, 5 years, all the way back up to the time you turn the machine on. But it's the machine that's creating the effect. So that means that even in an extraterrestrial civilization, if they turned their machine on, let's say 10,000 years ago, then it's possible that they could visit us anytime during that 10,000 year interval. Or if we encounter them, we could do the same. But but once again, this part, the part that I've been telling you is as far as the extrasolar planets and the potential of life, that has a scientific basis. Whether or not, as I said, any of that life has found us, that's speculation.
Exactly, or is more advanced than we are, even by 1,000 years. That's right, or even 100 years, perhaps. Okay, I mean, there must be some interest in the work you're doing. I mean, surely there's some agencies, that have taken an interest in your work.
Well, as a matter of fact, there were some agencies that took an interest in my work, but I'm very careful about dealing with the military because the thing is that it's a very complicated situation. I'd have to have guarantees that the work that I'm doing would not just be something that would be taken away.
Sure.
And, and that's reason why I've shied away from groups like DARPA. I mean, it doesn't mean that I wouldn't accept government funding, but I would have to have some sort of guarantees that what was happening would remain as public, knowledge, and not something that would be have a cloak of secrecy around it, in which I would even be possibility that I would be kept from my own work.
Yeah, that's right.
That's the tricky portion of it. The thing is that as far as the general public is concerned, yes, there has been a large interest by the general public. As a matter of fact, at my university, University of Connecticut, I do have a funding possibility through the University of Connecticut Foundation. However, it hasn't brought in a large amount of money that's needed for that. And I am, in fact, thinking about other possibilities now. In fact, there's this crowdfunding is a possibility that I'm thinking about exploring. And there are other possibilities. One of the other possibilities is just getting people more aware of what I'm doing. That's why my book is quite important to me, because the book was written, Time Traveler was written not just simply as a science book, a popular science book. I actually wrote it so that it was actually a memoir with the science built into it, because I wanted people to have an interesting story to read, but they would also be getting an accurate portrayal of the real possibility of time travel and other things that are happening at the frontiers of modern physics. So that was another aspect of my book associated with it. The other thing is that I'm hoping that is that a feature film might come out of it. Now, that actually would bring my story to a huge public, and that might be the sort of thing that would help even more with the sort of funding. And I should mention that there have been people who have been interested in making a feature film. In fact, one of them is the well-known director, Spike Lee, who actually has written a script associated with my book. And that's something that I've been very excited about. So there are these different avenues, but it does require the necessary funding, and people have been interested in it. And in fact, that's one of the things that I've been very pleased about being on your program, is the fact that you were interested in the real possibility and interested in the work that I've been doing.
Oh, it's just incredible stuff, and it's so fascinating. And having the chance to read your book, because not all books I do, like you say, it's a memoir, and it's really is I would highly recommend the book as well. Where can you get the book from as well?
Well, the easiest way is Amazon. If you go to Amazon.com, then you can get the paperback there, and the paperback is gotten at a bargain price. But that would be the fastest way for anyone to get a copy of the book, is from Amazon.com.
Okay. And what final message would you want to give the audience?
Well, the thing is that to me, I think it's important to realize that eventually we will be able to manipulate time, and we will be able to become more masters of our destiny than we ever have been able to. And I think it's important to realize and think about those possibilities. But I also think that for me, in thinking about my own life and my own particular journey, I think it's important to realize that the only thing that any of us really have is the present moment. And it's very important to live that moment to the fullest.
Well, Professor Ronald Mallett, thank you so much for joining us today.
Thank you.
Well, we've come to an end on today's show. Don't forget that you can listen and watch all our past interviews on The More Show's official YouTube channel. Remember to subscribe to our YouTube channel for new daily shows. You may also find out all past and upcoming guests via themoreshow.co.uk, and do like us on Facebook and Twitter for the latest updates. So until next time, be safe.
The More Show is in partnership with Ozark Mountain Publishing, taking readers beyond the unexplained.